So recall from previous pages that ADM stands for average deviation from the mean. On this page, we'll compare the average deviation from the mean as a measure of spread to other ways that we've measured spread in the past. So here below we have an example. We'll be measuring variability in a few different ways. The following dot plots show the potassium content in 76 cereals. We'll compare children's cereal to adult cereal. Which type of cereal has more variability in the potassium content? Okay, so just kind of by looking at it, just really quickly, I see that so the top dot plot is the child cereal, so they have it listed here, and then the bottom is the adult cereal listed here. It looks like, just on first glance, that I think the adult cereal has a lot more spread. The children's cereal looks like most of the dots are measuring in the smaller amount, because it looks like here 0 is on the left, larger numbers are on the right, just like we're used to. X-axis goes left small, right large. The adult cereal goes as high as somewhere around 330. The children's cereal, the highest value matches up to about maybe 110, somewhere like that. So I guess that's just people like kids don't care about potassium, they just care about the sugar and the taste, right? But adults might care about vitamins and things like that that go into it. But let's see. So as I say here, we can visually see that there is more variability in the potassium content of the adult cereals than the children's cereals. We can measure this spread in 3 different ways. So first, let's try using overall range. The range of potassium content is larger for the adult cereals than for the children's cereals. So that's kind of the first thing you notice, I think. Just without really digging into the numbers, you just kind of see all the dots sort of condensed in a small area for the children's cereals, but kind of spread out more for the adult cereal. The children's cereal set has a range of 90 because the highest value minus the lowest value, 110 minus 20, is 90. But on the other hand, the adult cereal has a range of 315 because the highest value is 330 for, I guess, those that want potassium in their cereal, minus 15, the lowest value, for those that don't really care about potassium in their cereal. So let's see. Now we'll move on and look at a different way to measure it. That's a good way, I think, just right away you see that, and anyone can kind of understand that, even if they don't have much of a background in statistics. The next way we'll do IQR, the interquartile range. So cutting it into 4 pieces like we've seen before. The IQR, the interquartile range of the adult cereal set, is larger than the interquartile range of the children's cereal set. The adult cereal set has an interquartile range of 80, since for that set, Q1, which is the largest value in the first quarter, is 80, and Q3, which is the largest value in the third quarter, is 160. The children's cereal set has an interquartile range of 30, since for the first set, Q1, the largest value in quartile 1, is 35, and the largest in quartile 3 is 65. Notice that here we use the median as a measure of center. The median is marked with a red line. So here we have it here, and then we have it here. Interquartile range measures spread about the median. So a lot of these measures of spread and measures of variability, they only work for certain averages or mean. So mean or median, we want to only use one. So for interquartile range, we just use median, we don't use mean. And then for standard deviation, we only use mean, not median. Now lastly, we'll use what we were using before. The average deviation from the mean. Now we're not talking about median anymore, we're talking about mean. So it kind of depends. In certain situations, like we said, you might want to use mean, some you want to use median. So whichever it is, median, you're probably going to use quartiles. For mean, you're going to use what we're about to do. The children's cereal data set has an average deviation from the mean of 22. So remember, you just find the mean, and then you literally measure how far away each of all the data values are from that mean value that you calculated, and then average all the averages. It sounds kind of crazy. The average, yeah. Anyway, notice here we use the mean as a measure of center. The mean is marked with a blue line. Average deviation measures spread about the mean. So that might be a good thing to note. If you haven't already done that in your notes, average deviation from the mean, you only, well, I don't know if I want to say equals, but use it when you're talking about mean as a measure of variability. But then we want to use probably quartiles or interquartile range for the median. Yeah, so it's not like you have a choice. It's usually you've already chosen you want mean or median, and then therefore you're kind of left with using one of these. Let's see. So they've set the median here, but like they said, with the blue line for both. Yeah, and the average deviation from the mean for the children's cereal, they said here, is 22, and the adult cereal set has an average deviation of 55. So obviously, that's 2.5 times the amount of the children's cereal. So definitely, no matter which of these three methods you use, we come to the conclusion that the adult cereal definitely has a lot more variability, no matter which measurement you use. So based on this example that we just saw, we might expect the data set with the larger range to have the larger average deviation from the mean, but this is not always true, as we'll illustrate in the next example. You know, instinctively it seems like that should be the case, but in this example we'll show that that's not always the case. We're going to compare the range and the average deviation from the mean. Which data set has more variability? On the below, okay. Our answer to this question depends on how we measure variability. So when we initially saw in the previous example the two dot plots, it looked like, oh, the values were more spread out from left to right. You know, the range, the highest value minus the lowest value, was larger for adult cereal, but that might not always be the best way to measure it. Especially this example kind of has a strange dot plot, one you wouldn't expect, because in this top one, I guess they're calling it set B, I don't know, we don't really know the context, I guess, but most of the data is contained in a small range, I mean fairly small, but then there's one value very large, way far away from those other data values, and one very small. So I don't know how often you would see that, probably not super often, I guess, but this is just a case that proves that you shouldn't always assume that higher range means higher average deviation from the mean. That might not quite be true. So you're looking at this set versus this one down here, set B, or sorry, we looked at set B, now it's set A. There's kind of a smaller range, you know, the highest minus the lowest. The lowest is 0, the highest is 100, so the range, yeah, as they show here, would be 100 minus 0, which is 100. But for set B, the highest value here is, what does it line up with? 200, and the lowest is 0. So it would be 200 minus 0, which is 200. So really the range for the top one is larger than the bottom, but if you're kind of interested in most of the data being condensed in a small space, I guess this one was kind of like it has less variability in that sense. Most of it's close to the mean or the median. There's just a few that are out there on the way left hand or the way right hand side. So yeah, like I said, it kind of depends on how you are measuring variability. So now we'll look at more of the average deviation from the mean. We haven't calculated that yet. If we use overall range to measure spread, yeah, we'd say that distribution B has more variability because it had the very high point and a very low point. But our answer will change if we use average deviation from the mean. So let's see. Average deviation from the mean, of course, that would take a lot of calculations, so we're just kind of assuming that whoever did this calculation did it right. In distribution A, which is on the bottom, the average deviation from the mean was 41, but in distribution B, the average deviation from the mean was 23, which is smaller. That's the opposite as it was when we talked about there's just the range by itself. So that's because the one on the bottom, set A, it has a lot of values kind of off to at the ends. The highest value is 100, and there are quite a few that are in that range, or in that area, I guess. And then the lowest value was 0, and there are quite a few, you know, the two highest peaks here are at the highest and the lowest, 100 and 0. Whereas in set B, you see that most of it's condensed, the highest peaks are right in the middle. It's more of a, a bell curve shape, as they call it, that one. But this one, it's kind of a strange, you don't see that very often, the set A that's on the bottom. It kind of curves, almost like a parabola or something you've seen in previous math classes. So I guess just don't always assume that variability, when we talk about which set of data points has the most variability, we might not all be on the same page on that. It kind of depends how you measure variability.